Hi, I'm doing my first video on spectroscopy. My name is Gurpreet, and today we're going to look at spectroscopy, which is a subject under bioorganic or organic chemistry, and this is solving spectroscopy problems using the NMR and IR. So the first step in solving spectroscopy problems is figuring out calculating the degree of unsaturation. There's 3 simple steps to follow. First, you're going to count the carbons and plug that number into the formula 2n plus 2 when you have a molecular formula, and where n equals the number of carbons in the molecular formula. This number would become value A. For number 2, you would count the number of hydrogens in the molecular formula, and that would become value B. Halogens count as hydrogens, so that'd be Br, Cl, I, and there's a number of others. And nitrogens count as one less hydrogen, so they would take one hydrogen away. And you can just ignore oxygen. You're going to plug those numbers into the formula. The formula is degree of unsaturation equals value A minus value B, all divided by 2. Now we're going to look at a sample problem, which is very easy. The problem is C8H14OBrN. There are 8 carbons. So you're going to plug in 8 into the equation. Just 2 times 8, which is 16, plus 2 would give you 18. You're going to count the hydrogens. Now, if you look closely, there's a nitrogen and a bromine. So the nitrogen would take 1 away, and the bromine would add 1. So technically, they get canceled out. So you still have 14 hydrogens. You're going to plug in value A and value B into the formula, which gives you 18 minus 14, which is 4, divided by 2, gives you 2 degrees of unsaturation. So this formula would have 2 degrees of unsaturation. Now, right here we have some cheat notes. For number 1, double bonds add 1 degree of unsaturation. 2, rings add 1 degree of unsaturation. And there's a simple rule that we have, and that's if there are 4 more degrees of unsaturation in a benzene ring, and also if it has 6 or more carbons, it's a benzene ring. Knowing the degrees of unsaturation in a molecule is very useful and important because it's easier and it's useful when trying to determine the structural formula from a molecular formula.